Hi, everyone. Welcome back. We are in Unit 7. This is the introduction to Unit 7. We're going to do a little bit of remembering what we did earlier on this year because we did lots of rates and ratios at the beginning of the year, but it's been a little bit since we've done them. And so we want to take a look at all of the things that we already know before we really dive into the unit. So, first of all, let's start thinking about rates. Rates, remember, is how fast or how often something happens in a given amount. And often it's a given amount of time, but it doesn't have to be, but often it is. So, for instance, it was a gorgeous weekend this weekend. I hope you were able to get out and enjoy it. I did, and I love to collect rocks. And so, as I was going along, when I found some cool or interesting rocks, I would collect them. And so, I have some rocks to show you, and I have a rate. I made a rate table for how many small rocks I collected, and I made a second rate table for how many big rocks I collected. And the time I'm going to show you is in minutes. Now, one of the things that we talked about and learned about earlier this year, and hopefully you're remembering it, is that for the sake of finding constant rates, we're going to say that something happens at a constant rate. Means every minute I found the same number of small rocks. At every minute, I found the same number of large rocks. Now, we know that in real life, very often that's not going to happen because maybe I didn't find some for a while. I was walking along, didn't find any. Or maybe it was time for a picnic. So we stopped and had a picnic, and I wasn't collecting rocks at that time. Or maybe there was an area where I was like, wow, there was a ton of cool rocks. And so I collected a lot at one time. So we know that it doesn't always happen exactly the way that we're going to say it does. But for the sake of learning about rates and ratios, we're just going to pretend we don't know about that. We're going to pretend we think like, yep, Miss Gilbert is out walking. She's finding rocks every minute. So I'm going to say that as I was out walking, every minute passed and I found 4 small rocks. After 2 minutes, how many small rocks did I find? Well, I hope you're saying twice as many as that because it's 2 minutes now. So now I found 8 small rocks. How about after 3 minutes? I hope you're remembering that we're going to keep counting. This is counting up by 1. This is counting up by 4. So after 3 minutes, I found 4 more, which means I'd found 12 rocks. It's keeping going up by 4. That's kind of a hard 4 to see. Keeps going up by 4. After 4 minutes, I'd found 16 small rocks. After 5 minutes, how many had I found? 20. Now, could I keep going? Well, likely so. I mean, if you're out on a nature walk, probably you're not doing it for 5 minutes. That's not a very long nature walk. So, as I keep going, I could keep adding on with each minute that passes, I would add on 4 more rocks. Now let's look at the big rocks. Big rocks are a little bit harder to find, probably because other people already like to find them too. So each minute went by and I found 1 big rock. After 2 minutes went by, how many big rocks had I found? I hope you're saying 2. After 3 minutes, 3. So these ones were counting up by 4. Those small rocks were counting up by 4. 4 more every time. The big rocks are counting up by 1. Each minute goes by, I find 1 more big rock. Now, let's pause a second and take a look at what that looks like. This is a rate. Remember, it's against a constant thing counting up, like time. 1, 2, 3, 4. First time, second time, third time, fourth time. These are 2 rate tables. we're gonna look at some rocks, and then we're gonna come back and talk about the difference between that and a ratio table to remind ourselves of that. So hold on, and I'm gonna show you the rocks I collected. Okay, well, first I should tell you that the rocks that I like to collect in this particular hike are ones that are like almost oval or almost round and smooth and flat. So those were the kind of ones that I was really interested this time when I was on my hike. So you can see these are actual rocks that I collected, and not just me. So my family knows I love great rocks too. So they sometimes would help me find them. But you'll notice that with the exception, there's a couple that are just really interesting. This my boys found for me. I thought that was really sweet. I don't know if you can see that. Oh, I can't tell you. Oh, there we go. Looks like a heart. So that's cool. And we were a little surprised about this one. Looks like a triangle. You don't see triangle rocks very often, so we thought that was kind of neat too. So these are the rocks that we collected. Now, so you can see that the number of small rocks is quite a bit bigger than the number of large rocks. When we can take and talk about something, not just how often it happens per time or per single situation, we can compare how often the two things are happening per time or per single situation. When that happens, we often take out the time or take out the amount of occurrences, and we just talk about the amount of the two different things. Well, that's the difference between rates and ratios. When we're talking about ratios, we're talking about the amount of small rocks compared to the amount of big rocks. So let's look at what that looks like for a table. Okay, so let's look at the difference now between the ratio table and the rate table we just saw, the two rate tables we just saw. So ratios, remember, are the amount of one thing compared to the amount of something else. Where the rates were the amount of something compared to a constant, like how much time had gone by. The ratios are one thing compared to another. So notice that the table looks a lot the same and also a little different. Instead of having the two different rate tables, each with the time in minutes and the number of rocks, that one was over here, remember? And the big rocks and the time was over here. So small rocks and the time, big rocks and the time. If you think back and remember that, now what we really did is just took those two tables and squished them together. Since the time in minutes is the same, we don't need to actually have that in both tables. We can just put it on the side of one table. Now, we can also see that the small rocks we're comparing to the big rocks. So after 1 minute, I found 4 small rocks and 1 big rock. After 2 minutes, I'd found 8 small rocks and 2 big rocks, 12 small rocks and 3 big rocks. So this is a ratio table because it shows these two different things. It compares them. Now, sometimes on a ratio table, you won't even see what's going on is how often is per whatever it is. In this case, it's per minute. Oftentimes in a ratio table, they take that out. You won't even see it. So let me go ahead and erase it here because that very often is invisible in a ratio table. You'll see it in a rate table, but once they put the two or more rate tables together to make a ratio table, it becomes invisible. And you just have to know this is the first minute, the second minute, the third minute, or the first time, the second time, the third time, like that. Now, you might have forgotten, or you might wonder, well, what are those circles up on top? What do those mean? Up here, that means, let me get my black marker here, that is the basic ratio. Now, you might remember from earlier units that what that means is those numbers are the smallest group of whatever it is that we can get that has the same comparison, the same amount of one compared to the other. So, for instance, 16 small rocks and 4 big rocks, well, that's not the smallest amount of groups together that we could have because both 16 and 4 can be divided by 4. 20 and 5, we know that's not the smallest because they can both be divided by 5. 8 and 2, they can both be divided by 4. But what can 4 and 1 both be divided by? Well, if you're thinking about facts, nothing, unless we go into fractions or decimals. So they already show us in this right here. We already have the basic ratio. Sometimes we need to find it. Here we already have it. So for us here, the basic ratio is 1 and 4. Now let's talk about how we're going to say those ratios. So if you think back to earlier this year, let me turn this a little bit. There we go. If you think back to earlier this year, we talked about there are a few ways we could write this. We could write like that. We could write it, do you remember? So we could write it 4, 2, 1 with the word TO in the middle, 4, and then TO, 1, 4 to 1. We could write it and say it still 4 to 1, but instead of writing the word TO, we put those 2 dots up and down from each other, the colon, 4, colon, 1. But we still read 4, 2, 1. Do you remember what another one was? You might remember that it looked like a fraction, 4 to 1. And we talked about how would you know that this was a fraction, talk about 4 wholes, or if it was a fraction, it was a ratio 4 to 1. And the answer is context. You have to know what those numbers are talking about, what they mean to know. In this case, it's a ratio, the number of rocks, of small rocks compared to big rocks. Now, remember at the beginning of the year, we also talked about that these numbers have to follow the words. So if we're talking 4 to 1, the number 4 is coming first. What word does that have to follow? Small rocks. In this whole section right here, we're talking about small rocks compared to big rocks. And we have to know that we're talking about the small rocks first compared to the big rocks second. So when we see the numbers, 4 comes first, 2, 1 comes second. 4 small rocks compared to 1 big rock. So the numbers have to follow the words and the words have to follow the numbers. They have to be in the same order. So is this the only way we could talk about this information? I hope you're saying no. No, what could we do? We could switch it around, couldn't we? Now, I'm going to get rid of this and put this over here. So the small rocks compared to the big rocks is in black. What if I switched it around and talked about it as 1 TO 4, 1 to 4, or 1 colon, 2 dots above the top and bottom is colon, 1, 2, 4, or 1 looks like a fraction, 1/4, but we're going to read it as 1, 2, 4. Now what am I showing? I'm showing big rocks to small rocks. So remember, there's the words, big rocks to small rocks. Big rocks comes first. So the number of the big rocks has to come first. Big rocks to small rocks. So it has to be number of big rocks to small rocks. So 1, 2, 4, 1 colon, which we also read as 1 to 4, or what looks like 1/4, but we actually are going to read it as 1 to 4 because we're talking about ratios. I hope this is feeling somewhat familiar for you. Let's talk a little bit about unit rates before we go on. You know what? I changed my mind. So sorry about that little transition not really being a transition. So I decided I actually needed to show you what the 4-to-1 looked like based on just my pile. I'd showed you my pile of rocks, but what that actually looks like in real terms. So I'm going to notice I have a pile here, but what I'm going to do is I'm going to put, we said it was 4-to-1 or 1-to-4, depending on if you're talking about big to small or small to big. So what I decided to do is I need to show you there's one big rock and 4 small ones. One big one and 4 small ones. So hold on, I'm going to do that a second. Okay, so you can see the big rock compared to 4 small. One big, 4 small, one big, 4 small, one big, 4 small, one big, 4 small. Now, that's the essence of ratios when you're thinking, is it the same ratio? The question is when I had all these rocks together, they were just one big pile of small and one big pile of big. But we can see the same ratio is true, the same number of big ones compared to small ones, no matter how many I take out. For instance, if I took out this bottom row, it's still the same ratio. It's still one big rock to 4 little ones. What if I took out the second row? And now I have 3 big rocks and 12 small ones. The ratio is the same. You can still see that every time I have one big rock, I have 4 small rocks for that same one big rock. Now, I'm going to put the other ones in. What if I went out and collected at the same rate again, collected more, so that I had 7 big rocks? What would the ratio have to be? Well, for each of those additional big rocks, I'd have to have 4 more small rocks to keep the ratio the same. That's how ratios get bigger and smaller, is by taking both the big ones and the small ones away, or cutting them in half or something like that, so that the same ratio stays, blank to blank stays the same. Okay, one of the things we started thinking about this fall was unit rates. And remember, the word unit means like one. So when we talk about a unit rate, it means something for out of every one of something else. So unit means one, and so a unit rate is out of one of something. So that's a little bit hard to understand just with words, but the examples really help us understand it. So here's some examples. You might be driving along in the car with your family, and you might say, "How fast are we going?" Your family might respond, 70 miles per hour. That's the abbreviation for miles per hour. So 70 mph, 70 miles per hour. What it means is we're going 70 miles per hour. Now there is a number, if you remember from the fall, there's a number that's invisible in this, somewhere in there. There's some invisible number. Do you remember what it is or where it is? Well, I hope you're saying it's that invisible one. That's what makes it a unit rate. We're going 70 miles per hour, 70 miles per 1 hour. There's an invisible one in there. When you hear the word per something like per hour, there's an invisible one. It's 70 miles per 1 hour. So remember the words, the other words we remembered were per also means each or every. So we're going 70 miles each hour, 70 miles every hour. Now, again, we know that that's not always the truth, right? Sometimes we might go a little faster if we're passing someone. We might have to slow down if we get clogged up in traffic. Maybe someone has to stop and go to the bathroom. So we know that we probably don't actually drive 70 miles every single hour. But when we're talking about constant rates, to understand a constant rate, we're just going to pretend that we do. We're going to pretend we have the cruise set. We're not getting clogged up. We're not going fast. We're not trying to pass anyone. We're not looking around for whether there's any police or whatever. We're just simply driving 70 miles every single hour. What about our babysitting rate? You might do some babysitting, and the person you're babysitting for needs to know how much to pay you. So they would say, well, what's your babysitting rate? You might tell them $6 per hour. Now you'll see this written like that, kind of that slash. That's actually like the fraction bar or the division bar. So $6 out of every hour, $6 per hour. Now what's invisible in $6 per hour? It's that one. $6 per 1 hour. So every 1 hour you babysit, you earn $6. If you babysit for 2 hours, you earn $12. 3 hours, $18. Could you babysit for a part of an hour? Well, sure. You could babysit for 2.5 hours. In that case, you would have to figure out also what to get charged for the half an hour. And I bet you could do that. This, though, because it's a unit rate, it's out of one, not out of a half. So we're talking about out of each hour. What about your family has to pay for where you live? It might be the rent, it might be mortgage, however your situation is. But you might ask your family, well, how often do we have to pay the rent? And they would say, once per month. Now, once, that word means one. You can hear the one in there. Once per month, one time each month. Now, I put the word each to help us think about it means every one. You go to the doctor and they might take your pulse. If you go for a checkup, they usually take your temperature, take your pulse, they measure how tall you are, they measure your weight to kind of get a sense of how healthy you are. So one of the ways that they check to see how healthy you are is to take your pulse rate. You might go to the doctor, they might take your pulse rate, and it might be 60 beats per minute. And again, this time I used that slash to mean per, 60 beats per minute. So what's invisible in there? It's that one. Every minute, your heart beats 60 times. So after the first minute, it's beat 60 times. After the second minute, 120 times, etc. So there it is again, per minute. Per meaning each or every, and the unit rate meaning something out of one something else. I hope that clarifies that a little bit. All right, thanks for watching our introductory video. Tomorrow we'll get started and we'll dig right in with lesson 1. Remember, you can always re-watch this video if you need to through the unit. Also, you can go back and watch some things from Unit 1 and relook at in your book for some things at Unit 1 if that helps you as you're going through the unit. Good luck. See you next time.